All right. So I think I met many of you yesterday. For those who don't, my name is Peter. I work for Prezi as an engineer and tech lead on the client-side development. So what is Prezi? I guess most of you know, but basically this is Prezi. So this is a zooming presentation software that has the idea that you can make people be better presenters if they have the ability to make use of space. Also, as we like to think about it, we're a major competitor to PowerPoint. Actually, we're in a good way because we have around 40 million users, so it's pretty cool. So today I would like to talk to you about a couple of stories, how we use Haxe, which is, I think, a bit different than the typical gaming use case that you're working on, so it could be interesting for you. Also, on the second part, I would like to open some conversation, or at least just throwing the idea that we think that Haxe is a very good platform to develop for the web. So we very much like the JS backend. So about Prezi, what you see here is just a screenshot from the editor. So our story, for those who don't know, because we were here last year and 2 years before, but I guess we always have new members. So Prezi is originally a Flash application running in the browser and in Adobe Air on the desktop. And it's pretty big. It's a productivity app, something like Photoshop or GIMP. Not as complex, but it's still quite feature-rich. You have to insert all kinds of content from images and videos and free drawings and shapes and be able to resize them, crop them, and group them, and all this kind of stuff. So it's one of the biggest ActionScript code bases out there, but as Flash is getting an abandoned platform, we were thinking about how to switch technology and how to move forward with our web client. And of course, that's how we met Haxe, which we immediately liked because it's a very cool language, modern language with first-class functions and type inference and even macros, which is really cool. So we immediately loved it and started playing with it. And I have to tell, we did some crazy prototypes. So for example, we have our desktop version, which runs on Adobe Air. But how do we swap it out or try to swap it out using Haxe? Well, we took some ActionScript code, our original Prezi stuff, ported the viewer part to Haxe. So we got this cross-platform viewer code, which was, in theory, to be playing Prezi on any platform. But what target to choose? Now, we didn't want to choose the Swig or ActionScript backend, because that's the platform we were trying to move away from. We were thinking about the C++ backend and tried it. Kind of like for the reasons that were mentioned yesterday, we didn't really pursue that approach because it is not really easy to use as a library in an application because of the API and memory management and how you link it. So we had this idea that why not use JavaScript, which is a very easy backend in the sense that the compiled code is has a one-to-one mapping. You can even easily debug it. And also, you can just basically embed a JavaScript runtime everywhere. So what we did is we compiled this to JavaScript and embedded it in a Google V8, which powers Chrome. This is a JavaScript execution engine, I guess most of you know, written in C++. So we could actually embed it in an Objective-C Cocoa application. So this stuff was running in the Mac. And it was, working actually. We had once a prototype which was an OS X desktop Prezi application using the JavaScript backend embedding an execution engine. Of course, it's a bit tedious to work with the JavaScript code running inside an interpreter. So you have to do these bindings through C++. So you want to make a very narrow API. So this was basically just being able to load the Prezi, and then the forward and backward keys were mapped, which were going through this C++ V8 interface. So the key is that you want to make sure that your stuff that's running inside a JavaScript engine has a narrow interface. Now, in a different project, we have this issue with zooming that we have to be pixel perfect on every platform, because if you zoom, even a pixel difference gets very big. And this is something that I guess most use cases don't have. For example, text rendering is just available on any platforms. but it's not good enough for us because they have these just small pixel differences. And last year, Laurent from our company was presenting about these challenges. What I would like to show you now is how the architecture actually ended up in this project. So this is actually something that we have in production. So this is the browser. We have Prezi as a Flash application running. This is indicated by this black box. And of course, we didn't rewrite the whole text rendering from like really scratch from parsing a font file because there's cool stuff out there that you can use. So we didn't want to reinvent the wheel. And there's this library called Halfbus, which is a shaping engine. It is able to parse the fonts and tell you where the different curves in a font, the glyphs, how the shade should be positioned. It's an industry standard library written in C++. So we had this idea that we somehow have to use this and as a foundation for our text rendering. But how do we run it in the browser? It's C++. Especially, how do we run it in Flash? So the way we went ahead is that you can use mscript then to compile the CPP code to JavaScript. I see some of you are smiling, so you know the tool. This is a really cool tool. Actually, I think even Quake was ported and runs in the browser using this cool tool, authored by Alan. So you get this JavaScript module, which you call it Halfbus.js, with its own memory management. The way it works actually is that since you're going from an unmanaged stuff to a memory managed stuff, basically it allocates the heap as just one big array in JavaScript, for example, and then plays around with it. And then, now that we had some JavaScript code, we could actually run it in the browser, because obviously you can execute JavaScript in the browser. So the way we wrapped it is that we did some new, this is the new text rendering on the top that you see. This is written in Haxe. This is like the cross-platform text module that we wanted to have. And what it does is that it has a part which is compiled to JavaScript, which wraps the Halfbus, this shaping engine, as kind of like a backend to support text rendering. And this is used by our Flash application, namely the other part of this same module, which is compiled to Swig. So the front end is something like insert these characters, delete this text, make this bold, and stuff like that. So these high-level text operations. And what it does is that it uses external interface, which is a standard Flash API for calling out to the browser. It uses external interface to communicate with itself, compiled to JavaScript, and actually shape out, or lay out the different characters in the text. So this was very nice, was working, but how do we get to run it on Adobe Air? Because we have a desktop version as well. Actually, I'm using the desktop version to present now. So here we have an Adobe Air application, the Prezi. But how do we run the JavaScript? Well, the cool thing is that Adobe Air ships with an embedded WebKit. So it has an HTML loader and the web view. You can just load HTML stuff. So we could basically reproduce the same trick, but not like calling out through the external interface to the browser, but rather launch a WebKit using the HTML loader, and then run the JavaScript, which was using. OK, so let's rephrase again. So we have this cross-platform module, which one part of it is compiled to Swig, which runs in Adobe Air, and that calls into the embedded WebKit to call itself, compiled from Haxe to JavaScript, and use the JavaScript text shaping, which was cross-compiled from C++. It's a working code. There was only one problem with it, that we have this enthusiastic Korean user base. They love Prezi. Even one of the presidential candidates, I think, used Prezi to promote. Maybe that's why he lost, I don't know. So the Korean fonts are very big. It's like 5 and 10 megabyte stuff, which is, if you load it in this embedded WebKit, the Prezi was loading for like 30 seconds, which is unacceptable, or even longer, I think. So we had to do something about it. And we figured that V8 is a much more powerful engine. It has typed arrays and this type of stuff. So we should use that. And we found that Adobe Air has this cool feature that you can actually plug in native extensions called A and E, which are just C extensions. It's similar to the Java GNI interface, for example. So you can just call out into native code. So what we did is we implemented a C library which embedded a C++ V8. and plugged it into Adobe Air, and then used the same trick again. So basically, we had here the real backend, so the C++ text shaping compiled to JavaScript. It is read by our own Haxe stuff that was compiled to JavaScript. And we were calling it from Adobe Air through this native interface. It's kind of the same pattern, except that this channel was even more layered or more complex, because first you have to call into C through this FRE interface, which is like plain C functions that the native extension can have. And then in these functions, we were actually, I had some C++ code which launched the V8, loaded the JavaScript that was cross-compiled from Haxe and C++. So yeah, Haxe is magical. So we really like this, that we can make this stuff work. And one of the things that we learned is, well, it's kind of like a different topic, but so one issue we had, we already talked about it actually with a couple of you yesterday. So we have this, it maybe looks enterprisey, but the way you build modules, or at least the way we like to build modules, is that they are pretty isolated. You have like this text rendering module that I was talking about. It's a self-contained stuff. When you run the build, it fetches the dependencies from somewhere, which could be like other modules of us, or it could be Haxe libs and all this kind of stuff. Then you run the build and test, and then you package it up, you wrap it, and then you publish it again to your repository so that other projects can pull it in. And it's really like, just for an example, it's not like from some kind of generic enterprise presentation, but so for example, in our case, in a JavaScript pipeline, what we have is that we download other stuff that our library wants, that our module wants to use. Then we have some phase where we generate Haxe externs for our code automatically from other modules that are not written in Haxe, for example, but we want to use them in a typed way. So for example, here we have an extra step. Then you run the Haxe compile, then you run the test. But then we want some, we're using require.js, or maybe you want to use some other module loading system in JavaScript, so we actually wrap the Haxe JavaScript file that is produced, so it in itself is not runnable in the browser. So you have to always have these post-processing steps, like, for example, wrapping it in proper require.js headers and configuration, and then you run obfuscation and minimization on it. This is closure. And then we bundle it up with resources like images and other stuff, and then we deploy it to CDNs and our own repository where you can download it if, for example, some other module uses this text rendering. So my point is that typically, if you're building a bigger projects or if you're doing this kind of modularization, then you have these build pipelines and your own build tools. And one issue that we had with HaxeLib is that it was pretty hard to integrate it directly. First of all, it would be cool if you could, if you have this dependency management, and the HaxeLib dependencies are seen and treated the same way as the rest of the dependencies. So if, for example, our text rendering depends on, for example, Harvbuzz, or it depends on a math library or something like this, you also see, and it's our own stuff, not HaxeLibs, it's seen along with the HaxeLibs the same way. And also we had an issue with the HaxeLibs being global, so that you have this global HaxeLib path in the user home, which, for example, if you have a continuous integration system where you have like preset images, it's not that easy to actually change it for your project. It's quite, it can get quite flaky to, for example, always override the global HaxeLib path to your own project path and download the dependencies that are specific to your project. So we ended up actually circumventing the HaxeLib stuff and our own build system, which is based on Gradle, by the way, but it's not that important. But the important thing is that what it does, it doesn't use HaxeLib to install the HaxeLibs and doesn't use the -lib switches in the Haxe compile, but it just downloads manually from our own repository all the HaxeLibs that are required for the project and extracts them to a local folder and just puts them on the class path. So basically we generate the HXML for the Haxe compile ourselves, and all the HaxeLibs are put in as just source paths, as if they were our own code. So this is like if I had a single and very easy change request, I guess here, but Nicholas already knows about it, and all of you know about it, that it would be really cool to have a local package management, just like NPM has a more flexible way to manage the HaxeLibs. So why did I give the title Haxe as a web development platform because it's still the most important platform for Prezi. So we're really interested in how we can use Haxe for the web. And we're not into Swift and Swig anymore, so we want to compile to JS. So what are the options when you want to work on the web? I just listed here a couple of ones. So you can do plain JavaScript, the newcomer from Microsoft TypeScript, or the kind of old-fashioned enterprise GWT, that's the briefcase, Dart from Google, Clojure, CoffeeScript. You have a lot of options, and of course Haxe. So which one to choose? Of course, we had some experience with Haxe, so for us, Haxe is in this race. And this is actually one of the most interesting things for us about Haxe, that based on this standard, kind of like more mainstream options, we also know about Haxe. So it is in the race for us. Now, of course, there are a lot of things that you consider when choosing your technology, like language features, performance, of course, tooling, the set of existing libraries, so how mature it is, how big the community is, how easily you can onboard new members, for example, to a new technology. And what I wanted to talk to you about today is that I think Haxe is actually in a very good shape when you're in the compile to JS race. So one of the most important things, I think, if you're building a web app, because the web is a so developed ecosystem, you want to interface with the native libraries. We have a lot of cool stuff written in Haxe libs, I think, but I think it's realistic to say that we cannot just rewrite everything from scratch and reinvent the wheel all the time. So there are all these cool JavaScript libraries that you want to use. For example, if you want to do some GUI, AngularJS, or Facebook React is the new cool thing. We're using Mocha for BDD testing, for example. There's the need to go reactive this year's like slogans, so RxJS and BaconJS. Or if you want to do vector graphics, 3JS, for example, or Rafa, 3JS for WebGL and Rafa for vector graphics. So in a real project, a bigger project, typically what you end up with is you want to pull in a lot of libraries. And I thought that I would check how different languages do that. And I think you'll like the results. So here's, for example, GWT. This is Java stuff that compiles to JavaScript. And the way you can use native JavaScript libraries is that you have this special command block here, this special notation, which you can use to embed any verbatim JavaScript. So for example, you can say to do this Fandango stuff, the new compressive Fandango. The only thing is that, of course, you have to access somehow, for example, the window object. And this is done via this $WND sign, which GWT provides you. So it binds it to the global window object. So this is actually a two-liner, pretty simple stuff, I think. So it's quite OK. Now in Dart, it's completely different. This has its own runtime. So the way it can work with JavaScript is actually the similar hell that you have with programming JavaScript through an interpreter. So you have to do it all this reflection layer. First, you create a JavaScript execution context. Then you're using this context to create objects. And you have to specify all the stuff like reflective lists or like as strings. And then the way you can, for example, invoke a method is this call method. And there you also specify the method as strings. So you have this reflective layer to work with any code. And I bet I didn't really work with it, but I bet you even have to worry about the different memory model of JavaScript. So you end up retaining and releasing JavaScript object if you're not careful enough. So this is pretty messy. Now TypeScript, on the other hand, is just a superset of JavaScript. So that's one of the best features and what they're strongest in. So you can just write any plain JavaScript inside TypeScript, and it would be working and compiling. Except, of course, you need the types. So these examples now I'm presenting, these are about how to use the native JavaScript in an untyped way. So you can just say new compressive Fandango, except that would throw a TypeScript type check error because it doesn't know about any com and any Prezi and any Fandango. The way you can alleviate is similar to Haxe dynamics. So once you say that, OK, I have something called any, then the type check is that just skipped by the compiler, and then on window, and of course all subsequent accesses. So you can just say new window compressive Fandango. You could even say a bit more. For example, you could actually declare a window which has a com property, which is of type any. So you can use, for example, window in a typed way, but the com then becomes untyped, and you can just do anything with it, and you promise that it will work when it will run actually in the browser. And of course, you know Haxe. It's also a very simple thing. You can use this untyped keyword. Yesterday, he was presenting it in C++. It works in JavaScript as well. You just say untyped.js, and you can insert any string that will be injected into the compiled or the generated output. So it is also a very cool two-liner. It's a bit bad that you have to use these string blocks. It's not as nice, for example, in TypeScript, but it's only in the entry point, for example. So once you assigned it to a dynamic, you can just use Haxe syntax instead of like reflective strings to work with it. So it's, I think, quite nice. So it's not bad. So this was like how you can use it in an untyped way. But the whole point of using a compiled to JS language is that if you wanted to do the untyped thing, you could program JavaScript. So the main point is that you want to use some type system. And the way you can do it in Git, for example, where you cannot define external classes, so you have to create basically a Java Fandango which wraps the native JavaScript Fandango in. So basically you're creating this wrapper class and you're delegating to native JavaScript in each method. Now the reason why it's messy is that in the first example, when we were just calling into JavaScript, that was the same two-liner, so quite easy. But when you want to actually use the Java part from JavaScript, you have to use this full qualified syntax, which is like ugly. And if you check it, it's a very big boilerplate. So you probably either want to generate this or you don't really want to go this way. Of course, once you do this, you can just use the Java Fandango in a natural typed way in Java. So how to do it in Dart? Oh, I didn't try. So using this context, it's something similar to, I think, than the Git version, just even worse because you have to do the delegation always using these contexts. So in TypeScript, it's very easy. It has a similar, actually it's not so much similar to the Haxe extern, but it has this C-type philosophy of headers and implementations, kind of. So basically you can just create a header type of thing, in this case something you call DTS, a definition file, and you export basically the interface. You promise that there will be a Fandango with the constructor and the doIt method with these types, and then you don't have to actually have the implementation when you compile, and there's not even a linking phase or anything, so it will just look for it in runtime. But the compiler, basically you're promising the same way as with Haxe externs, that there will be a Fandango, and then later you can just use it in a simple typed way. And of course, Haxe has the same feature, so we can just define an extra class Fandango with all our types, and then use it in a typed way, which is, I think, really cool. You can even rebind to a different name, just like you presented yesterday. So why I showed you this is that we think about this feature as, okay, just one of the features out there. We all know about it and use it. But if you compare it in the compiled to JS world, it's actually very cool. So it's quite competitive. If you look at this scale from Dart to TypeScript, how easy it is to interact with native JavaScript, I think Haxe is in a very good position. It's almost as good as TypeScript. The only difference is that in, for example, TypeScript, there's this movement now called definitely typed. Everyone's hyping about it this year and maybe last, that they are collecting all the externs. So there's this huge library of, I don't know, 100 or 200 libraries that have external definitions written for them. Of course, they are on different level of maturity, so some of them are better maintained, some of them are just where one-shot works, but still it's very cool that there's a place where you can go and just, you have all these existing libraries available in TypeScript. And even some tooling is starting to pick it up. So for example, I just heard that WebStorm is able to import these definitions. Even if you're just doing plain JavaScript, it can import the TypeScript definitions and then do autocomplete for you, and it can provide hints and warnings based on these definitions. So it would be awesome if Haxe had a similar support on it, so, or could really leverage this. For example, we could have, I don't know, Haxe libs that are just externs, for example, and then that's a central repository for fetching external definitions for all kinds of native libraries, not just for JS, but I guess for all platforms. Or we could have also it on GitHub, but I think it would be really nice to have a similar stuff like definitely typed in TypeScript. So for us, and I really hope that for the rest of the world, Haxe becomes an option in the compile-to-JS world. That's the story I wanted to share. Questions, guys?
Hi, I was wondering if you converted your whole old ActionScript app, or did you just convert part of it? It looked like you just converted part. And have you thought about converting the whole thing?
Should I repeat the question, or it doesn't matter because the stream doesn't have voice anyway? Anyway, we heard. Okay, so we only converted part of it. So the whole code base is, I think, around maybe 200,000 lines of code or something like that. So we didn't convert all of it. We converted just the part that is enough to play the Prezi. So you cannot edit, you cannot add more content and do all the changes. And so basically just have the feature that you're seeing now. You can just render the Prezi and move around. That's the part we converted. I don't know the size. Maybe it was, I don't know, 20K. So probably like 10% of the code. Of course, we thought about it, porting the whole thing. And the reason we didn't do that is that it actually took much longer to port even this part than we expected. That's mainly because, I guess it's related not so much to the technology, but so how do you do this project? It's either like a complete rewrite. You send away a team with 5 developers, and then in half a year or a year they come back and have the Prezi, but that's very risky. Maybe that's not even the Prezi you want them to create, because your main product also evolves along the way. So a better approach, I guess, a more safe approach is to always port back. And as you port the code to Haxe, you compile it back to Swig, and then you have the code live. It's in production, so you have a shorter deadlines. You can track the progress better, and also you know that all the changes are kind of like pulled in the Haxe code base as well, so it's not a separate rewrite. But to do this, it's very risky. So for us, if you basically, if you commit, you have to count with that if the continuous integration is green, that commit could go out to the 40 million users this evening or next day or whenever. So basically, it's the same thing. I just port something to Haxe, and then and if I commit that, and that's converted back to Swig and goes to the live users, so that's very slow to work like that. So we ended up working very slowly in Haxe because of this backport and because we have a live product to work on. Also, I think the architecture, of course, so like the original Swig code base is kind of like starting to be old one. It started 4 or 5 years ago, and I guess if you've been on such long project, you know that by this time it's becoming legacy always, so you don't like the way it is architected. And if you do this continuous porting to Haxe and use it back in the live product, you will get the same architecture. You cannot really rewrite the stuff. So we thought that it's a too big project to port the whole thing.
About definitely typed, I believe Bruno suggested that we made a converter from the externs to Haxe externs, and I've been working on that actually, and we have a converter which just parses the definitely typed externs and creates Haxe externs. Wow. I don't really know how well it works because I don't use it, so I'm kind of looking for someone to maintain it, but I guess it would be really nice to properly design that so that we can just use it, and you should get pretty much every extern for free.
That's great. I didn't know that. We should promote it more, I think, and we'll look into it. That's very cool.
Good.
Okay. Yesterday I've been bothering Franco and other guys about IDs and corporate stuff. You have a fair amount of developers, a huge project, and continuous integration, continuous delivery, and so on. So you are quite corporate-ish.
Yeah, in that sense. But we like to think about it as very
Do you really use Sublime Text?
Sublime?
Yeah.
We used it. So in this project, I think Back then we used Sublime. So we switched to IntelliJ maybe half a year ago, 1 year ago, in Haxe.
Okay.
Because
So.
But 2 years ago we used Sublime.
And on the build pipeline, are you using something like Maven or Gradle or?
Yeah, we're using Gradle to build, and we're using Ivy repositories to store the artifacts. And we actually, we have quite a tooling around Haxe in the sense that, so we have this Gradle kind of plugin that generates, for example, the Haxe commands that we use. So we don't type the Haxe commands ourselves, but they are basically based on the build definition, it assembles the wall. It knows where the sources are, what are the dependencies, what to use, what flags to use.
Okay, cool. One other question, because in my previous job I was working with fonts, and I remember that 2 years ago there was one other guy from Prezi talking about the problem about fonts. And we have been porting to a Swig file a free type from C++. And we didn't even consider to convert C++ to JavaScript and use an external interface. Why did you choose that way? Just because you were aiming to the web only? Or it was something easier,
no, because,
maybe?
Well, we were always aiming for desktop as well. I think it was because we just didn't want to port and rewrite.
Yeah, we didn't rewrite. We used Alchemy.
Oh.
So.
But. Okay, I have to think about this. But so if it was true that Flash text rendering is the same on all platforms, then we wouldn't have had the problem in the first place. So I think you cannot. So what we do is we're using curve to and line to draw the fonts.
Yeah.
So in the end, and we don't let Flash draw the fonts. And for that we have to generate. So we're kind of like we're starting from the font file, parse it, and then find out where the different characters are and what their shape is, and actually draw it. I don't know how that would work with Alchemy. I'm not familiar with that.
Basically, you cross-compile. It's the same thing of the thing that
but the same with
to JavaScript.
Okay, I remember. Yeah.
But it cross-compiles to ABC, ActionScript bytecode.
Yeah, I think that would work then.
Yeah.
Okay.
It worked for us.
Yeah,
so
it would work, except we also wanted to move away from Flash. So this means that we have to be on Flash.
Yeah.
And we had this idea that while we're doing this project, so this is like it was a new project, and we had the concept that new projects should not rely on Flash anymore.
Cool. Bravi. It's a good project.
Thanks.
Any question? Okay.
Okay, thank you guys.
Thank you, Peter.